Hey guys, this is Group 8. This is design and development of our cantilever beam. I'm Aiden.
I'm Soraya.
I'm Jonas.
I'm Emily.
For our first design, we decided to have an open oval shape that allowed us to save maximum amount of the material while avoiding the structural instability associated with the sharp edges. By leaving an inch on the side completely full, we ensure that the parts of the beam that interact with other parts of the force system are as strong as possible, and at the same time minimizing the weight of the final result.
For our first test, our beam had a large oval cut out in the center, which caused noticeable flexing and twisting under the applied load. This added flexibility, however, allowed the beam to handle stress effectively. At 5 pounds, it showed moderate bending and it ultimately withstood up to 32 pounds of force before snapping. When it did snap, the hook end of the beam had bent multiple inches below the original position. The point of failure was near the opening of the mount, about 1 inch inwards from the unhooked end. This failure likely occurred because the part of the beam inside the mount was rigidly constrained, while the hooked end was able to flex freely, which created a point of high torsion that the beam couldn't handle.
So for our redesign, from test one, we saw that there was a lot of flexing and torquing and twisting from our prototype. So to accommodate, we filled up the open oval space with rigid X-like bracings. These bracings create lots of triangles, and triangles are a stiffer and stronger structure that will better resist bending, twisting, and deformation with just a little bit more weight added on.